Today we're going to talk about the quadratic formula. What is the quadratic formula and why do we need it? The quadratic formula is used to find roots and zeros of our quadratic functions. The roots and the zeros are the x-intercepts of our parabola. So where the parabola crosses the x-axis, those points are our zeros and those are our roots as well. Any equation can be used to put into the quadratic formula. There is no limitation. The one stipulation about using the quadratic formula is that the equations have to be in standard form. So to have an equation in standard form, the exponents need to be in descending order. So our standard formula for a quadratic expression is ax squared plus bx plus c. The quadratic formula can be hard to remember. As you can see over here to my left, that the equation is rather lengthy. To remember the quadratic formula, you can always use a memory trick. And the memory trick is often putting the equation to a song.
Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you know the quadratic formula. Now you know the quadratic formula.
Now that we know the quadratic formula, let's try a couple of examples.
In our first example, we have the equation 6x squared plus 3x plus 3. The first thing that we need to do is identify our a, our b, and our c. Our a term is 6, our b term is 3, and our c term is also 3. Now we can plug into the quadratic formula. We will begin with the opposite of our b value. Since our b is positive 3, we will write down negative 3. Then comes our plus or minus sign, and we can go into our square root. Then comes our b term squared. So I'll input 3, I will square it. Then I will subtract 4 and multiply it by the a term and the c term. So 6 and 3. I will put all of that over 2 times a, and our a term is 6. The next thing we need to do is evaluate the b squared minus 4ac underneath our square root. When I take 3 squared minus 4 times 6 times 3, I get the square root of negative 63. The negative 3 is still in front, then our plus or minus sign, and it's still all over 2 times 6, which gives us 12. Now we need to simplify our square root of negative 63. Remember, when we have a negative square root, we need to incorporate the imaginary unit of I. So this can change into I square roots of 63. Now we can break it down using our factor tree and look for pairs of the same number to become our perfect squares. So 2 factors of 63 are 9 and 7. 7 no longer breaks down, but 9 becomes 3 and 3. Since I have a pair of 3's, I will put those in front along with my I, and the 7 will stay behind underneath the square root sign. I still have my negative 3 and plus or minus sign in front and my 12 below. The last thing I need to do is simplify the numbers in front, so the negative 3, positive 3, and 12. They all can be divided by 3. Negative 3 will become negative 1. Positive 3 will become 1, so we can just leave it as I. The square root of 7 will follow, and our denominator now is 4. So our final answer is negative 1 plus or minus I square roots of 7 all over 4.
And that is how we can use our quadratic formula to find roots and zeros of our quadratic function.